Episode 25 of the World of FPGA podcast. Have you ever asked yourself what happens during FPGA implementation? In this episode, I try to give an answer. Welcome to the World of FPGA podcast. I'm your host, David Kirchner, and I will lead you through the world of FPGA. And now, let's begin. In the last episode, episode number 24, we talked about the synthesis of a design. But this is only a part on the way to get the design into an FPGA. The next step is the implementation of the generated netlist into the FPGA logic. This is now the transfer into a real chip. Implementation consists of two major steps: placement and routing. Let's come first to the placement. In this step, all the components of the netlist will be placed into real cells in the FPGA chip. Here we have a lot of constraints. I/O ports, defined blocks like PLLs or gigabit transceivers, and so on. And timing between all these blocks is essential to get the connection, the right timing between these elements. High-speed paths must be placed together. There must not be too much long lines between those blocks. And after placement, we go into the step routing. So in the step routing, all the placed blocks have to be connected. And here we also need to take constraints into account. The lengths of the routes to the FPGA create timing differences between signals. In high-speed systems, picoseconds are important. Clock networks have to be used for global clock signals, since FPGAs have dedicated clock networks, and fast signals are getting routed before slow signals. At the end, every connection from the netlist must lead to a physical connection in the chip. And after this process, after the place and route, a programming file can be generated. This is very tool dependent. Some tools generate automatically a programming file, other tools have to be triggered to generate this. And a little bit is this implementation similar to PCB design. The implementation process has a lot of similarities of the process of layouting a PCB. There you get a netlist from the schematic tool and you have a list of components. In the FPGA case, these components are the different function blocks in an FPGA, like lookup tables, flip-flops, DSP, block RAM, and so on. On a PCB, you have some integrated circuits, resistors, capacitors, diodes, transistors, and so on. Connectors, of course, for the I/Os, some I/Os. And when you have placed all the parts on your PCB, then you route the copper traces between the parts or the pins of the parts to get a connection of all the signals. So there's some similarities, but in FPGAs this is done automatically by a tool, and I guess nobody will do this by hand. Maybe there are some 1% of the designs which will be done by hand, but I guess the most designs are placed and routed automatically. The exact details are part of the company's knowledge, so I cannot go deeper because I have no deeper information about this process. But on the top level, now you can answer the questions: what is happening while the FPGA gets implemented? Further information can be found at world-of-fpga.com/WFP025. If you found this episode helpful, please rate it on Apple Podcasts and share it with your colleagues and friends. That's the end of today's podcast episode. Thank you for listening and for your attention. So I say goodbye, here next time, your David Kirchner.